Hey guys, we're finishing up our chapter on sampling with some sampling wisdom. So yesterday we talked about different ways that we could introduce bias into our sampling methods, which would draw us off target. We also going to learn about some ways that we can reduce variability by increasing our sample size. Also, we can reduce variability by blocking and stratifying as well, which we'll get into a little bit in the next chapter with experiments. So if you guys need any help, make sure you're reaching out. I know some of this stuff can be a little bit challenging. The textbook is another good resource, honestly. I'll be reading through the textbook, especially with this chapter, because a lot of it is vocabulary. So if you can hear me talk about it, you can see me try to present it, but also if you can read it from another perspective, hopefully between those three, you can really kind of get a grasp of what's going on with the vocabulary here. So let's move on. So sampling, selecting, randomly assignments, all that good stuff. All right, so let's go to parallel examples. So here we have our population, which is our entire pot of soup, right? From that, we pour our bowl of soup, and then from that bowl, every time we take a bite or a spoonful, that's like a sample from our sampling frame. Now, we're not sampling from the actual pot itself, right? We're sampling from the sampling frame. That's where we're gonna eat out of, right? So the key here is that we want to make sure that our sampling frame matches our population as best we can. So for example, if we're doing a poll and we want to know about registered voters, or likely voters, so who's going to go out and vote, right? From that, we want to create our sampling frame of hopefully a voter list, like the registrations, right? But not everyone is registered to vote who ends up voting and other stuff like that, right? So we want to do our best, because when we're calling and randomly selecting people, or we're sampling from our sampling frame, not from the actual people who are going out and voting on the day of the election, right? So we want to make sure that our sampling frame or our voter list matches the registered voters or the likely voters as best we can. And if those two are off, then we're going to have some issues. So that's where you get some underrepresentation. So for instance, military ballots, or homeless people, or for instance, people who are incarcerated, as long as it's not a felony and they still have voting rights, stuff like that. So could you be incarcerated for non-felony offenses? I don't know. Anyway, kind of interesting. So basic general idea is that we sample from a sampling frame, not from the population itself. So the whole point, our sampling frame is like the list of all the potential people that might be caught up or randomly selected. We want to make sure our sampling frame matches the population that we're trying to draw conclusions on as best we can. Another thing I don't think I mentioned, well, we'll just mention it again, is convenient sampling. So it's a type of sampling. It's a bad type, right? It's the lazy type, where you set up a booth and you have people come to you for signatures or something like that, right? For a petition, right? So instead of allowing people to sign or like unsign somebody else's name, you're not really polling. It's just really, can you get enough enthusiasm for people to do it? So anyway, like for instance, 99% of the people who have the internet had the internet. That's amazing. That was a convenient sample, really stupid. Another issue you'd have if you go to the mall and you're trying to bring people into the malls. Well, if you only poll or survey or interview people who are at the mall already, those are the people that you already won over. What you really want is to find the people who are buying things online and who are not going to the mall. Then you want to try to see what you can do better in order to encourage them to come to the mall to spend their money there instead of online. All right, a pilot is also a really good idea. So before you spend all your money, you design your experiment, or in this case our survey. Before we spend all of our money doing it full scale, we might want to run a pilot. And a pilot is using the same sampling frame and the same questions we were going to ask, just to see if we can detect whether or not maybe there's some bias in the wording, maybe there's some confusion. If there's any issues, we can fix it before we go full scale and spend all the money. That's a great idea. So running a pilot, good idea. Multi-stage sampling is also when you have a combination of several methods. So a simple random sample and you're stratifying, that's pretty common. You could also do just any combination of those, I'm pretty sure is possible, and that would be called a multi-stage sampling. So if a lot of times we're stratifying, we're breaking down like male and female, but then we'll also do a simple random sample of 15 high school male and 15 high school females. So that would be like a combination of stratified and simple random sample. So anyway, it's called multi-stage sampling. All right, then the difference between bias and variability, you've got some really nice charts there on your worksheet. So if you want to read through that, probably a great idea. It's pretty much what I'm presenting anyway. So Bias and variable. So once a sample has been, okay, yeah, there should be a C there. Once upon a time, once, like once, okay. All right, once a sample has been tainted by bias, you cannot recover it. You can't correct for any bias methods that you used. So you must plan a strategy to avoid bias. So you can't like fix it, okay? So be careful. Bias is the consistent repeated deviation of the sample statistic from the population parameter in the same direction when many samples are taken. So if we're constantly off, the poles are constantly off, that means there's some sort of bias going in some way that they're gathering the data. Again, probably response bias like we talked about. Why are the polls wrong all the time? So that's because of bias, okay? So we have to plan to be able to recover. We can't fix it once we have that bias. We have to start out with a better, scrap it, start out with a better method. Like the question they asked, and so they asked like not whether or not who you're going to vote for. They asked the question, who do you think your neighbor is likely to vote for? Because people will be more likely to say their neighbor is a Nazi than they are a Nazi themselves. So that just makes sense, you know, because you can punch my neighbor in the face, but not me. So perfect idea. There you go. And they actually didn't have as much bias whenever they asked the questions that way, which is wonderful. All right, so yeah, bias happens when the sampling strategy is flawed and the sample over or under represents the population, which is wonderful. We don't want bias. All right, variability is how spread the values are from sample statistics. So if we do a sample, we do another sample, how much variation do we have from sample to sample, okay? Large variability means that the results of sampling is not repeatable. So hopefully if we did the survey multiple times, we would get very similar values. So how far spread out that is, that's called the variability. All right, so good sampling method has low bias, meaning it's representative. The sample is representative of the actual population, meaning it's close to the target, right? And low variability, which means it's repeatable. So it's precise and it's also accurate. So whether or not it's precise is the variability, and the accuracy is how close it is to the center of the target, which would be if it's representative. So our different examples here, graphical displays, the one that we want, the ideal is low bias and low variability. So we keep repeating the samples over and over again, we get the same marks, and they're close to the true proportion, which is what we wanted. Or mean, or whatever we're measuring, saltiness, whether or not the peas are done, you get the idea. All right, high bias and low variability means that we're consistently off target, but we're getting consistent marks. Okay, that's still not good, right? Low bias but high variability. So all of our marks are close, but they're spread out, so it's still a wide range. So when you increase the sample size, or it's just not repeatable. High bias and high variability. This is bad. We're off target and it's really sloppy. And then the ideal, of course. So to reduce bias, we use randomization. So a simple random sample is a perfect way of doing it. We can also reduce bias by stratifying. So there could be even from one random sample to another random sample. If we think male and female has different opinions, then we want to break it down. Do a simplified random sample, but do it multi-stage where we also stratify to reduce some variability from like 18 and 12 or 13 and 17 from the male and female breakdowns. That could happen in a random sample. So we want to fix it so it's 15 and 15 male and female, so we don't have any extra variation. All right, good to go. To reduce variability of samples in a sample random samples, use a larger sample size. So the smaller the samples, the more they're going to vary. The statistic will vary, like the mean or whatever. It's a central limit theorem, essentially what's going on here. But whenever we increase the sample size, as long as we don't have any bias and we're using a simple random sample or some sort of randomization process going on, then there'll be less variation. But larger samples are more expensive, so that's not always the best way to do it. So helpful advice, and of course I have to use my Austin Powers voice on this one. So it's not the size of the proportion or it's not the size of the sample, but how you got it. So it's not the size, love. It's how you. Never mind. It's how you got it. I almost said the other one. Anyway, so Austin Powers, absolutely wonderful, terribly inappropriate. You probably don't even know the movies because you were too young, still too young, far too young. Anyway, so don't worry about necessarily just having a larger sample. Larger sample is not necessarily a good thing if there was bias in how the sample was collected. So if we're doing convenience sample, if we're not focusing on randomization and how we structure our survey, it doesn't matter if we collect a bunch of data. It's just a bunch of bad data, and we can't make good conclusions off of it. So really focus on spending your time and money designing a good experiment or a good survey, and then, of course, larger samples is going to reduce variation. So anyway, thank you, Austin. Appreciate it. Anytime, love. So spend time and resources reducing bias, not just gathering more bias data. Okay. Once a sample has been tainted by bias, it must be thrown out and can't be salvaged. So I know you wish that you could. Try to match the sampling frame with the population to avoid undercoverage. So again, watch out for people that don't have the opportunity to be represented by in your sample. That's undercoverage. If you have groups excluded from your sampling frame, undercoverage, don't claim them in your conclusion. So if you don't have a way of polling homeless people, then don't claim to speak on behalf of homeless people. It's that simple. Be transparent about your sampling methods so others can detect bias that you may have overlooked. So always, just like whenever we were removing outliers so that we could have better models, it's okay if we do, but just make sure that you're being transparent about your statistical practices so that others can peer review what you're doing and detect some issues that you have. And honestly, if you look at a lot of other stats that people do, even people who get paid a lot of money, you can detect some really jacked up and sketchy statistical practices. But anyway, not just in the surveys but actually like interpreting the surveys as well. People suck at it. No one knows what margin of error is. All right, a helpful advice on reducing sample variation. The variability of a random sample is based on the sample size of 100, not samples or the proportion like 10%. So for example, the sample of 100 Oklahomans will have the same margin of error as a sample of 100 Americans, even though clearly there are more Americans than there are Oklahomans. Even though it's a larger proportion or larger percentage, it really matters the number, not the proportion of the sample size. So here are two formulas for standard deviation in the sampling distribution models we'll use after Christmas. Notice the size of n is in the denominator that will reduce the sample to sample variation by the square root of n. So for both of these, probability of success times probability of failure, p times q, like 50-50 and the heads or tail thing. It's the square root of p times q divided by n, so it is the square root of n. So it's the inverse square root law, essentially what's going on here. So we can reduce the standard deviation by the reciprocal square root. Okay, same thing with standard deviation of means for the mean of the population divided by the square root of the sample size, which is our n. Okay, so both of these are square root of n in the denominator. Okay, so essentially if we quadruple or multiply by 4 our sample size, then our standard deviation, if we do 1 over square root of 4, which is basically 1/2, our standard deviation would be cut in half. Quadrupling the sample size cuts standard deviation or the margin of error in half. If we multiply our sample size times 9, then square root of 9 is going to be 1/3. So then our margin of error would decrease by 1/3. Anyway, cool stuff. Just checking. Various claims often made for surveys. Why is each of the following claims not correct? So we'll go through this, do it in our own time. It's always better to take a census than to draw a sample. So a census is like the U.S. Census in 2020 or whatever. Census is based on everyone. So that's when our sample size is everything. Like it's the entire population, or at least the best that we can get, right? So yes, it is always better to take a census, but it's really expensive. That's why we only do it every 10 years and we don't ask a ton of questions. So it's not always better because it's not feasible. We don't have resources for that most of the time. Unless, for instance, it was like my stat class. If I don't need to take a sample of my stat class, there's only 30 kids in there. I can get a census of the whole stat class. That's totally doable. Stopping students on their way out of a cafeteria is a good way to sample if we want to know about the quality of food. All right, so the people we really want to know about, we would be leaving out all the people who don't go through the cafeteria line. So the ones that probably would have negative opinions of the food, right? And I heard that you guys don't have enough nutrition, so you don't have enough calories in your meals that are being provided for free at the school. So yeah, there's some issues, aren't there? And I even know about it. Ooh, and I said something. Anyway, so stopping students out of the way, there's undercoverage. What about the students that don't eat lunch, right? We drew a sample of 100 from 3,000 students on a school to get the same level of precision for a town of. Okay, no. So again, it's not the proportion. It actually, the same sample size of 100 would give us the same margin of error because it would be divided by the square root of 100, which is a tenth. Anyway, whatever. Tenth of whatever the standard deviation of the population was, or the sample, from the sample. All right, a poll taken at a statistics report support website garnered 12,000 something responses. The majority said they enjoy doing stats homework. Okay, well, the sample size is large. We can be pretty sure that most stats students feel that way too. Well, the people who are going to that website is probably not representative of all the people who are taking stats. So we need to randomly select statistics students, not just doing, and also it's voluntary response. So if this was a poll that they put on a website, and if it was a stat website, how dare you? Yeah, online polls and statistics, those are contradictory. You can't do online polls. Oh my gosh. Somebody wrote that. This is funny. Anyway, so it's wrong on so many levels. Voluntary response. We didn't select them. We let them select us. It's not representative. Not everyone goes to that website who's a stats student. You also, so that you have under coverage as well. And it's a convenience poll. Again, there's no randomization going on here at all. It's lazy. Lazy, lazy, lazy. The true percentage of all stats students who enjoy homework is called the population. Okay, so it's called the population parameter. We have sample statistics. Okay, so that would be like the average from a mean, like a mean or a proportion from a sample. And then you have the population parameters. Okay, so the population parameter is like the total. So if we're talking about elections, right, that's the final popular vote or whatever, like the total number of people who voted for candidate X, right? The sample statistic would be from the proportion of people that we believe we're going to vote for candidate X based on our polls or from our surveys that we sent out. Okay, so the population parameter is what actually happened, and then the sample statistics are going to be all those possible proportions that we had from all the polls. Okay, kind of cool. 26, more survey questions. Hey, we're doing all right on time. Examine each of the following questions for possible bias. Okay, so we're looking for response bias, which is then the wording of the question. If you think the question is biased, indicate how to propose a better question. So what part of the question is kind of leading people towards one answer or the other? Do you think high school students should be required to wear uniforms? Okay, so the language should be required. It could be left out. So you could say something, are you in favor of uniforms in high school would be a better way of saying it. Like saying you're required to or mandatory or something like that. That language would kind of show a negative connotation. It's not too bad, but just change the wording. Given humanity's great tradition of exploration, right? So that's obviously kind of padding this up. Do you favor continued funding of space expeditions? So we need to get rid of this whole part right here, right? So clearly you're trying to manipulate people towards favoring it, right? So just ask the question, do you favor continued funding of space expeditions? All right, fuel economy. Occasionally when I fill my car with gas, I figure out how many miles per gallon my car got. I actually do that every single time. There's an app for that, by the way. I wrote down these results after 6 fill-ups in the past few months. Overall, it appears my car gets 26.4 miles per gallon. That was actually true from last year. This is real data. I used it, I think. Or it comes from the textbook. I don't know, but that's close. What statistic have I calculated? So we calculated the overall miles per gallon. What is the parameter that you're trying to calculate? So the statistic was the 26.4. That's what I calculated, the average miles per gallon. The parameter is the actual true miles per gallon for my vehicle, like the overall for all time miles per gallon, not just from those 6, but it would be the overall miles per gallon of the vehicle, which is what I'm trying to estimate with the average of my 6 fill-ups. How might my results be biased? Well, fuel economy actually changes. There's a lot of variables that go into it. So driving style, how aggressive I am, if I'm angry or not, if I'm listening to heavy metal whenever I'm driving, if I'm doing burnouts. Just kidding. Actually got on to somebody in a parking lot for doing burnouts. It felt pretty awesome. I didn't get shot, so that was good. It ended up well. What the weather, cold weather, hot weather, whether or not I'm running the air conditioning, if my windows rolled up, windows rolled down, if I'm on the highway, if I'm running in the city. So there's lots of things that if my tires are inflated, lots of things that could change the results. Okay. And move them off target towards what they should be. The EPA checks a car like mine to predict its fuel economy. What parameters are they trying to calculate? So the EPA is also trying to calculate the fuel economy. So what is the overall fuel economy for my vehicle or my type of a vehicle? So it's the same thing for the population parameter that we were trying to guess. All right, that's it. 20 minutes, not too bad. Shorter than the other ones. Let me know if you guys need any help. We'll do one more video. We'll start chapter 12 over experiments tomorrow, and then we'll have Thanksgiving break, so you guys will have time to get caught up. And then we'll finish up the last of experiments. If we get to come back, we'll get to do a fun activity in class. If we don't, then we'll just probably just do it next semester. So see you guys later. Have a good day.